A force diagram is a very useful tool in analyzing situations and the forces on our objects. Force diagrams give us the direction, the relative magnitude, and the location of the forces that are applied on an object. Here's an example of a situation. This is a woman on a subway who's holding onto a pole, and we see from the arrow that there's an acceleration on the subway pointed to the right. Here are the forces that are acting on this woman in terms of a force diagram. In that force diagram, we only look at our object in question, which in this case is the woman. There are 4 forces being applied to the woman. The normal force from the pole, we see that that's pointing to the right, and it's labeled with its symbol as well as the object that's exerting the force. Remember, we commonly call that the agent. There's also a gravitational force acting on her, pointed downward or toward the center of the earth, and that acts on her center of mass, which is why you can see that arrow is pointed downward here. There's also a normal force from the floor on her foot. We can see that arrow is pointed upward right here, and a frictional force from the floor that's going forward. And the reason that's going forward or to the right is because if there were no frictional force as the subway accelerates to the right, she would slip backwards. And so that frictional force is the thing keeping her in place. Now, in addition to force diagrams, we have a special type of force diagram called the free body diagram. In the free body diagram, we're treating our object as a particle rather than as something that has a shape and size. So here's our force diagram once more. Again, we have our whole object in this force diagram, and our force arrows start on our object and point away from it. And here's an example of a free body diagram that would be showing the same thing. So instead of drawing the woman, we represent the woman by a dot, representing the fact that we're treating her like a particle. And then we have the same 4 forces acting on her, but this time those forces start on the dot and point away from the dot. They have the same direction, and the arrow length is indicative of how large the force actually is. Anytime we're drawing free body diagrams, we want to make sure that we start with the dot, that all of our arrows have their tail end on the dot and point away from it, and that the direction and length is indicative of the force that is being exerted on our object.